Good morning, afternoon, and evening, everybody. Thank you for joining us today. This webinar will be recorded and the video will be posted on the IChemE YouTube channel. The slide packs will be available on request, and we'll send a PDF copy of the guide that we're introducing to everyone who's registered. Please submit your questions and comments in the chat box, and we'll answer them towards the end of the webinar. If we're out of time, we'll also send written answers along with the PDFs. So it's my pleasure today to introduce Professor Stefan Simons, the chair of the Energy Centre, who will be giving you a review of 2018 and looking forward to the work of the Energy Centre in 2019, as well as Mark Apsey, our lead on energy and resource efficiency, who's going to be launching our Energy and Resource Efficiency Good Practice Guide today. So without further ado, I'll hand over to the chair.
Okay, thank you, David, and greetings everybody, and Happy New Year to you all. Many thanks for joining us today. I'm Stefan Simons, as David Walker has just said, and I'm chair of the Energy Centre board, and it's my pleasure today to give you a brief overview of the highlights and activities that we undertook in the Energy Centre during 2018. Now you can see from this slide that I've given a subtitle of Planning for the Future, and that's because 2018 saw the 3rd anniversary of the Energy Centre, and so it was a time for us, the board, to reflect on what we had achieved and also to make sure that we've future-proofed our governance structure so that we could continue to provide a service to the IChemE and its members. Okay, so as I just said, the Energy Centre was launched back in 2015 with a mission to provide evidence-based chemical engineering perspectives on global energy challenges, including climate change. You'll see various electronic ways of contacting the Energy Centre, and I'll show these again at the end of my presentation. But those of you who are very keen-eyed will notice that the URL at the IChemE website is for the Energy Centre is a subset of its policy website, and that is very much a major part of what the Energy Centre is about, which hopefully you will see in a few moments. So we mustn't forget that the IChemE is a member organisation and its activities are led by members for the members. Hence, all the members of the Energy Centre board are volunteers and give up time from their day jobs to run the Energy Centre and help organise its events and outputs. As part of the IChemE, we want to enable its members to make influential contributions to solving major global challenges associated with the production and use of energy and the impacts on society and the environment. So we provide the IChemE membership with a voice on energy-related issues, access to policymakers, access to expertise, opportunities for continued professional development, and opportunities to expand their professional networks. The Energy Centre was launched on the back of a member survey on the energy-related priorities they wish the IChemE to focus on. Initially, the board intended to focus on all of these 6 priorities that the survey revealed with equal measure, but this proved too difficult to manage. Hence, we decided to narrow our focus on 3 key areas, namely carbon capture, storage and utilisation, the future of oil and gas, and energy and resource efficiency, whilst at the same time providing expert opinion and support in the other areas. Clearly, as chemical engineers, we should have something to say about the future production and use of the fossil fuels that are the mainstay of our industry. Being more efficient in the way we use resources can lead to additional carbon savings when combined with energy efficiency measures, and decarbonising energy production from fossil fuels requires large-scale process design, all of which chemical engineers have expertise in. And of course, all these priorities, including the others on this list, require systems thinking. And hence, that's very much what the Energy Centre is offering, particularly policy makers. So I'm now going to go on to show some of the outputs of the Energy Centre in 2018 and say a little bit about what we intend to do this year. So if we start with carbon capture and storage, we commissioned a piece of work led by the then vice chairman of the board and head of our CCSU task group, that was Professor Jeff Maitland, on the challenges and opportunities to delivering CCS on a commercial scale. The report, published in April, and you can see the front page of the report here on this slide, was aimed at policymakers and had numerous suggestions on policy measures that could help deliver large-scale plant. We launched this in London, and it attracted a lot of attention, and you can see that it led to the UK government appointing Jeff to its CCUS Cost Challenge Task Force, charged with developing the UK government's action plan, which was published the 28th of November 2018. So there you can see a direct influence of the Energy Centre on government policy and the involvement in that development of policy by one of its members, at least one of its members, I should say, because there were many people involved in writing the report. The laying out what we plan to do further on CCSU and get momentum generated from this report. This is what we're planning now, another series of reports focusing on the various very energy intensive process sectors such as cement and iron and steel manufacture. In other policy development initiatives, the Energy Centre contributed to the consultation on the UK Clean Growth Strategy, Technologies for Clean Growth. This was part of a multi-institutional effort led by the Royal Academy of Engineering, and again the response from the engineering institutions was published in November 2018, and you can find that on the Royal Academy of Engineering website. If I move on to future of oil and gas, that's been an extremely popular topic for us, probably unsurprisingly, being chemical engineers. Many of us are involved in the oil and gas sector, and many of the members of the IChemE are employed by that sector. And we know that there is pressure to reduce the use of fossil fuels. And what does that mean for the future of that important sector to us? So it's been very popular, and hence we've had many workshops taking place all around the world, obviously in the UK, but Australia, Malaysia, South Africa, and Qatar, gathering the views of the IChemE members in those countries on how they see the sector developing in their regions. Now, we've gathered all that information, and we will be publishing a report during 2019 on that. But at the same time, it's become an important area for us in terms of collaboration with the AICHE, which is something that we've always been keen to do in the IChemE. And it's this area that the AICHE feels very comfortable with and really wants to collaborate on. In fact, I had a message from them yesterday. They're going to be leading this through their fuels and petrochemicals division. And we're very pleased that we're going to be collaborating with the AICHE on this issue. 2018 saw the publication of the IEA's report, The Future of Petrochemicals. There were some very interesting conclusions from that report, particularly around the use, the importance that petrochemicals will have in the oil and gas sector as the use of oil and gas in fuels declines. Petrochem will become the major user of these important raw materials. So 2019 will see the Energy Centre and the IChE producing the chemical engineering view, because if you look at those that were involved in producing the IEA's report, it's not clear that chemical engineers had much of a voice in that. So we want to make sure that we respond to that report. Okay, energy and resource efficiency. This is seen, energy efficiency is seen as the low-hanging fruit for carbon dioxide reduction measures. Much has already been done in our industry on this, but we still waste a huge amount of the energy that we use and produce in our processes. Furthermore, it is increasingly recognized that making better use of resources, excuse me, in what is called the circular economy can deliver far greater carbon emission reductions than energy efficiency on its own. It's for this reason that we made energy and resource efficiency the major focus of our work last year and going forward. Mark will talk about this in more detail in a moment in regards to our work on the ERE case studies and the guidelines. But Mark is also leading on the development of the UK Energy Plan 2050 for BEIS. As chair of the working group of the Global Alliance Future Climate Engineering Solutions. He's doing this on behalf of the Energy Centre, of course, but we've been working with Future Climate Engineering Solutions since COP24 in Paris, where we argued that we already have the technologies to help us meet our emission reduction targets. It's from the Paris Agreement that these national action plans have arisen, and it's very pleasing that the Energy Centre is involved with the UK's work on this. I should say at this point that, of course, what I've shown has been quite UK-centric at the moment, and we do have board members from around the world, and we plan in 2019 to push what we're doing in all these areas much more on the international stage, holding events overseas, but also targeting policymakers in the various regions that we are represented in. Okay, you'll recall that I had a subtitle about planning for the future in the first slide, and as members of the IChemE, you're all very well aware that the past year has seen the IChemE undergo a major reorganisation in its governance structure and a refocusing of its mission to be the learned society for chemical engineers. It was also the year that the Energy Centre became 3 years old, and that was the specified term for the officers of the board. But since we were created in 2015, we were created without any real succession processes and procedures in place, and hence our priority for 2018 was to begin the process of board membership succession. So Jeff Maitland, who was with us from the staff, decided to step down from being a vice chair, and Jim Petrie was elected to vice chair international in March, but just for 1 year, and he was representing our interests in South Africa. And Mark Apsey himself succeeded Richard Darton, who was the other vice chair, in September. We've also elected several new board members, all with fantastic experience and expertise to offer the Energy Centre, and particularly on the international agenda. Takina Fabara, Head of Applications Engineering at Doosan Babcock, will take the leadership of the ERE task group so that Mark can focus on the VC role. Currently, we have a vacancy. We're looking for somebody with expertise on nuclear issues. So if you're interested, please do contact us. Finally, I should mention our Future Energy Leaders Forum. This consists of early career energy sector professionals who demonstrate potential to be leaders in the energy field in the future. Volunteer members provide support to deliver the Energy Centre's policy statements, research and reports, and lead engagement activities around the Centre's priority areas. We're extremely pleased with our Future Energy Leaders Forum. They are very enthusiastic, very active, and have organised some tremendous events. And in 2018, they organised the Trust in Energy, Forecasting Our Uncertain Future, which was held in London in May last year, and had panel members from Shell, IEA, the World Engineering Congress, ICL, and it was a great event. It's on YouTube. There's a link there that you can see. Please go and watch. You can see the whole event on that recording. Again, elections were important in 2018, so we now have a new chair of the Future Energy Leaders Forum, elected in July, Habiba Dagash, and the membership is becoming increasingly international. With the workshops that we've been giving overseas, there are always young people there who want to get involved, and they're encouraged to join the FEL and have done so in ever increasing numbers. So we believe that this is an excellent model for other activity in the IChemE to get our future leaders involved with chemical engineering. In 2019, the Future Energy Leaders is organising a webinar on climate equity, which is a very important issue. So how climate policies within countries, including policies directed at both low carbon energy development and resilience to climate change effects, can simultaneously build the capability of individuals and communities. So I encourage you to look out for the link to that webinar when it comes up. So that brings me to the end of my presentation. I hope you found that interesting. Here are all those links again, email, and Twitter, and you can also tweet. So please make note of that. You'll get copies of these slides. So, and if you're interested in anything that I talked about and would like to get involved with the Energy Centre, please let me know. So with that, I'm now going to hand over to Mark Apsey to talk about the work we've been doing on the energy and resource efficiency. So over to you, Mark.
Thank you, Steph. Good morning, everybody. Well, good morning, good afternoon, and good evening, as David said at the beginning. Thank you all very much for joining this webinar and giving up your time to listen to us launching the IChemE Energy Resource Efficiency Good Practice Guide and the associated case studies. I'm going to take about 15 to 20 minutes just to talk through the work we've been doing and give you a flavour of what's in the guide and where you can find the information. But first of all, I'm sure many of you on the call will have seen the recent report from the Intergovernmental Panel on Climate Change back in October last year, talking about the impacts of global warming if we manage to just keep the numbers to 1.5 degrees. And if we do that, we can look forward to a number of things. So sea levels continue to rise beyond 2100, intrusion in terms of flooding and damage to infrastructure in coastal areas, continuing biodiversity loss, increased acidification of the oceans, more extreme weather events, increased droughts in regions and so on. And the list goes on, and the risk increases as we get further away from 1.5 degrees to 2 degrees and above. And it's quite sobering stuff. Not only that, if we do want to limit and mitigate the impacts of climate change and get to the 1.5 degrees, we really do need to take some pretty drastic action. And I'm talking about we need global greenhouse gas emissions to fall by about 45% from 2010 levels by 2030. I mean, that's just 10 years away. And we need to reach net zero by 2050. And unfortunately, we're nowhere near on track. this is a projection from the UN Global Emissions Report in 2018. And in the graph on the left-hand side, you'll see it maps the trajectory of the historic emissions in terms of gigatons of CO2 equivalent, and where various policy scenarios will take us up to 2030. And the worrying thing is that even if we do manage to implement all of the conditional NDCs that we can see at the minute in terms of policies from national governments by 2030, this projection shows that we're still some 29 gigatons of CO2 equivalent over where we need to be in 2030. And you can sort of see, if you look at the green trajectory for the 1.5 degrees C range, how steeply we've really got to curb our emissions going forward from 2020, 2021 to meet that 2030 objective. Okay, so this all represents a huge challenge for the world and for us as engineers as to how we can really make these changes in the required time. And it's against this background that the IChemE Energy Centre decided to focus on energy and resource efficiency as one of our key topics. So to do this, what we looked at was we organised a task group, and we drew that from the members of the Leadership Forum, which Steph's already talked about, also from the special interest groups and other experts in the field, and directed by the Energy Centre Board. And we set about identifying a scope of work to help get things started. Very early on, we decided that the main audience for our output last year should be chemical engineers and members of IChemE. As a profession, we work in some of the most energy and resource intensive industries in the world, and therefore have a great opportunity, I think, to make a real difference. That's not to say that this content shouldn't be helpful more broadly, and I hope it would be shared and used as widely as possible. Steph mentioned the Future Climate Engineering Solutions Initiative, and that really is a combination of all engineering institutions working together to come up with pathways to and plans for 2050. So energy efficiency is an enormous topic, and having defined the audience that we really wanted to speak to in the first instance, we also needed to set some scope boundaries to focus our efforts. And we agreed to focus on a few things. So approaches to embedding energy and resource efficiency and circular economy principles into particularly process and product design, into process operations, commissioning, decommissioning, end-of-life plants, and into business models. And then we also wanted to think about some of the wider aspects, so cultural aspects of driving change within organisations and trying to tackle some of the barriers that typically arise when trying to implement this kind of work. So this scope really evolved into two tangible work streams, which the task group have been looking at over the last 12 months. The first, and the topic of the webinar particularly, was the creation of a good practice guide with the intention to help engineers and think really about how to tackle implementing energy and resource efficiency in your particular organisation, and act as really a starting point for that journey. And alongside that, we wanted to publish some real life examples of successful improvements that have been made in the form of case studies. And we've got a number that we're launching this week for case studies, but we are looking for more as well. And it's the good practice guide I'm going to spend most of the time looking at today. We haven't got time to go through all of the content in it, but I hope I'll be able to give you an overview of what's in it and then pick out some of the principles we've developed through a series of workshops, a member questionnaire, which hopefully many of you participated in last year, and input from experts in the field that we've consulted. So here it is. So we've really distilled things down in the guide into 10 key principles. Principles 1, 2, and 6, and apologies for the order there, but considering the whole picture, focus on the process and doing life cycle analysis, really can be grouped together, and they're about thinking about the real impact of the products we make in the processes we operate in terms of the whole system and life cycle analysis, from the very start to the very end of a product's life. Then if we look at 3, 4, and 5, they really group together around identifying the opportunities for improvement for energy and resource efficiency, and kind of give some tips of how to challenge our thinking and work out all the things that we could possibly do to make a difference. And then 7, 8, and 9 really group together and focus on thinking about what are the traditional barriers that make implementing energy and resource efficiency perhaps more difficult than we might all aspire to, and suggest some ideas for overcoming those. And then finally, the 10th principle that's made it into the guide. Whilst most of our dialogue's really been about climate change and greenhouse gas emissions this morning, Principle 10 really prompts us to think even more broadly about some of the ecological limits of our planet, and other things that we might want to take into account when trying to solve this immense systems problem that we've got. So let's take a tour through some of these in a little bit more detail. First up, consider the whole picture. So really, it's the starting point. If you're going to think about doing some analysis to see what opportunities exist for energy and resource efficiency, then the first thing to do is really define the right scope and boundary. Otherwise, you can end up quite simply fixing just one part of the system if you've drawn your boundaries too narrow, only to make things a lot worse elsewhere in the cycle. And the graph here is really trying to represent the life cycle of both a product and a process that come together during manufacture, and start people thinking about, well, what is the cause of the resource and energy that goes into a particular thing. And on the left hand side, the product life cycle, it really starts with product design. So this is the point when particular materials are selected to achieve a certain output, and often the focus at this point is on perhaps rightly customer quality, it's on robustness, it's on minimizing costs for production, and perhaps less so on the impacts on other parts of the life cycle, like, for example, the raw materials that you're going to need in the acquisition of those, the manufacturing process itself, the distribution, the use or reuse. So are things at design designed to be easily taken apart and recovered and used in a different way, and disposal. So where components are sort of locked together in the manufacturing process and are very difficult to recover the precious materials in them, then quite often they end up going to landfill. And similarly, if we look to the right hand side of the diagram here, when we're designing the process to produce a particular product, we do make decisions that lock in resources and energy to that whole supply chain without necessarily thinking about it at that moment. And this links quite well in, as I said, with Principles 2, which is about focusing on the process, and 6, which talks a little bit more about life cycle analysis. And there's a little bit of overlap, but really, if you're thinking about a life cycle from a product perspective and a process perspective, one of the things you might want to think about is doing full life cycle analysis. And there's a lot more information in the guide. The frustrating thing when you're doing life cycle analysis, perhaps, is that quite often the data is not available, and that can be a bit annoying. But I think the only point I wanted to make here was life cycle analysis is a discipline and a particular act, and can be quite labour intensive. But I was recently at an event chatting to a professor of life cycle analysis, and he summed it up pretty well. And he said, well, what really we need to be aspiring to is life cycle thinking, and making that our new habit. So hold the pictures in our minds, and as we do things, just think about the life cycle of particular products and processes. And you can look up some more about life cycles in the guide itself. So those first 3 principles really make us think about the way we use energy and resources from a total systems perspective. And it's important to work out what can practically be done in your supply chain next. So as engineers, we need to use numbers to really understand something, and we recognise that. It's just the same when looking to find improvement projects in energy and resource efficiency. The thing to do is really think about, right at the beginning, what you need to know, and then set about finding proportionate ways to measure it, whether that's kilowatt hours of electricity or kilograms of reject material or meters cubed of water. And you don't need to meter everything. I think that's quite a common misconception, and people can get quite excited putting meters in my experience, all over the place. But the important point is to think about what you need to know to fix the system that you've thought about at the beginning. Once you've got some data, then there's questions about, well, what sort of target should you set yourselves? And the principle we've put here is really around targeting the minimum. I had a really good conversation with the head of environment, health and safety for Toyota at a conference several years ago. And at Toyota, they have a very simple approach to setting targets for energy efficiency in his particular case. And And the way he looked at it was you need to work out what the absolute minimum energy and resource requirement is from a scientific perspective to achieve your target, and then set that as your target. Don't settle for modest incremental improvements, but be ambitious, and then constantly measure your performance against what the absolute minimum is that we could get away with for a particular output. So once you've got some data and you've worked out what data you need, once you've got some targets, then really you're ready to start identifying actual improvement projects. And I've been lucky enough to work with many organisations over the years, and all of them have their own names for this kind of process, whether it's energy audits or treasure hunts or kaizens or fast find fix events or some other kind of workshop. But the fundamentals really remain largely the same. When you're looking for opportunities, it's always a data-based effort, and it's always a team effort. So you need to bring in experts and stakeholders from all across the supply chain, especially in the context of the systems thinking and life cycle thinking we're talking about, to find out the things that will really work and that make sense and that won't make things worse somewhere else. And by having those conversations, I think you'd be surprised at the list of projects that you can find that can really move your organisation a long way to getting towards that minimum target, with the associated cost savings that normally come alongside such improvements. But that's not the end of the story. And to realise the benefits from any of these projects, and they really do need to be implemented. And whatever the project, implementation tends to take a pretty standard process from origination, which we've been really talking about, through to full business case development, where we do a little bit more engineering, if it's an engineering project, or a little bit more work on the numbers, and then into project delivery, so implementation of the particular project. Now, the problem is that despite the fact that many of us can see the necessary long-term benefits of doing a lot of these projects, there are often barriers to getting these projects through to the finish line within a particular organisation. And there's quite a few things like low energy or low material costs for an organisation, which then precipitates perhaps not or limited board level sponsorship or interest in the topic. It may not be financially attractive enough to do change projects that does cost money. Maybe organisations have better use of capital, or at least money that can be spent elsewhere and get a higher return. There can be a lot of fear of disruption and change, and that's not insignificant. If you change something, then you're taking a little bit of a risk, but you've got to do that to make things better. And there are short-term pressures within organisations. Whilst there's perhaps no, despite what we've all seen and can see from the IPCC and the UN projections, there's no real pressure for organisations as entities to act, and so it's easy to do nothing. So in the guide we talked about some of these barriers, and I think it is definitely worth understanding, if you're serious about implementing energy and resource efficiency, the types of barriers you're likely to come across within an organisation, because then you can plan your projects to overcome these things, and hopefully blast through the barriers and realise the benefits from the projects you've found. So just a couple of potential thoughts on that. So one option is to make sure you seek very early high-level sponsorship that makes energy and resource efficiency and organisational policy. It's easier said than done, but it is absolutely worth doing. I've come across many people in organisations with really good intentions, really get it, really understand what needs to be done from an energy efficiency particularly, but also resource efficiency point of view. And they come up with some great solutions, but because the management team isn't supportive or bought into the process, they can waste a lot of time, and then nothing changes. So get the sponsorship early, try and make it organisational policy. And one of the other barriers we mentioned there was really around funding and maybe the uses of capital within an organisation. And if internal capital for delivering these great projects turns out to be a barrier, then one option is to explore alternative funding options. One particular example from the energy efficiency business that I work in is energy performance contracting, where there isn't a shortage of investors out there willing to provide capital for energy performance contracts that provide guaranteed energy savings over an extended period of time. And these investors will typically accept much longer payback periods than your internal capital, when you're competing for that, would accept. And therefore you can make a lot deeper project changes, and you can not just pick off the sort of the easy wins in terms of control change and so on, but you can do deep energy retrofits of energy centres and upgrade systems and so on to the latest equipment, funded by somebody else, delivering savings for an organisation. And the only really requirement in terms of the organisation is to sign up for that for the period of time required for that investor to recoup their investment. So in summary then, for the principles we've looked at or so far, I think the first three are really about learning to see and thinking about the system as a whole life cycle and getting that habit of life cycle thinking. The next are really about finding opportunities. So be ambitious, find all of the opportunities as a team, and then finally really look to be action focused. So think very early on about how to implement those projects so that you can deliver benefits, and find ways to blast through these barriers that we've talked about. So much of what we've looked at and talked about is really focused on energy resource efficiency in the context of greenhouse gas emissions. But we do face other ecological pressures that energy and resource efficiency can help to mitigate. And the Stockholm Resilience Centre has done some really great work on identifying these ecological boundaries for our planet and attempting to work out in each case what the safe limits are for our continued existence. And I put the classic graph up here as a radar chart. So you've got all of the particular measures around the outside, and then various zones as you go out. So if you're in the green zone is within safe limits. The blue zone is really in a zone of uncertainty where we're facing increasing risks of tipping over the safe limit. And then the reddy orange zone really is where we're already over the limit in terms of what would be considered safe for a continued stable environment. And a couple of those are in the red zone, so things like phosphorus and nitrogen loading of the environment in the biogeochemical flows in the bottom left-hand side of the chart. We're already tipping over. And similarly, genetic biodiversity in the top left, we're by this research already over them. And then there's some others that we're getting more and more worried about. So climate change, we're in that blue zone and we're approaching potentially the limit, which we've talked about. And really, I think what we've tried to do in this principle in the document is give everyone an overview of what each of these particular other metrics are as a springboard to finding out a lot more about it. And I highly recommend looking into more detail around this thinking and this working. Okay, so that really concludes a really fast tour through the Energy and Resource Efficiency Good Practice Guide, which we've been working on for the last 12 months. We've also, as I said, developed a number of case studies for release, covering things like creating chemicals from waste material, generating electricity from low-grade heat, solvent recovery and recycling, material recovery from electronic devices, so recovering precious metals from things like computers, and also generating fuel from household waste with the Hero unit. This is very much the first batch of case studies, and the task group, and Takina is going to be leading on with this work in 2019, is actively looking for more examples from members to convert into case studies this year, with a view to building a bigger resource library for all of us as members to access and give us ideas for how to implement energy and resource efficiency going forward. Now, I think I'm just almost out of time, so before we go to questions, I'd just like to say a few thank yous to the team. As Stefan said, everyone who has been working on this gives up their time voluntarily. And in terms of the Energy Resource Efficiency Report, particularly want to thank Kit, Gareth and Julia and Karush for their work authoring and developing the workshops, sifting through all of the data and coming up with the 10 principles. Miles, Malcolm, Alana and David and Stefan really for reviewing the output and making sure that it made sense through the year. And then, of course, Energy Centre Board for sponsoring the work. The wider ERE task group, which I'm sure many of you are members, and the leadership forum, and then everyone who's responded to the survey last year, which we put out There was a great response to that, and it really helped to frame what we put into the document. Okay, so I think I'm going to hand David back to you to see if we've got any questions.
Thank you, Mark. So I'd like to begin by answering on the question I've had, which is when and where will the guide be available? So that is going to be emailed to all of you shortly in the next couple of days, and if you are in a hurry, it will be uploaded to the policy documents section of the Energy Centre webpage in the next couple of hours. So a more technical question on life cycle analysis. For the new technologies reducing energy demand, such as solar, battery technology, etc., how does the initial raw resource demand look against reuse and recycling, as the current materials used for manufacturing these products will also have a finite resource and an impact on the environment through mining and extraction processing?
Okay, yeah, no, this is a great question, and in the quest, very much like the quest in the UK at least, and the world, to shift away from or try and reduce carbon emissions in transport, and everyone dashed towards diesel to solve one particular problem and metric, if you like, which was CO2 emissions. We've created another problem, which is poor air quality and higher emissions of other things. I mean, I think it is something that is an issue, and there are finite resources. So if you think about lithium-ion batteries, there are finite materials that can be accessed to get into that, and some of them are in some difficult places to access, and they will run out. And it's certainly the case that I don't think the industry yet has quite got it right in terms of thinking about life cycle analysis for all of these technologies. What I would advocate is making sure that we do start to think about these problems. I mean, the fact that the questions come up, and I've had various discussions with other people about exactly how do we make sure we make all these renewable energy generating pieces of equipment to transition to a low carbon economy. How do we make those truly sustainable? And I think that's an ongoing debate, and something that we should, as chemical engineers, really engage with. I hope that answers the question. I guess we don't get feedback, so but if there's any follow-up, please drop another line.
I will keep you posted. So we also have a question. What was the current technology that produces fuel from household waste mentioned in one of the case studies?
So Stefan, do you want to take this one?
Yes, okay. So that's one of the case studies that I was involved in, because it's a technology that's been developed at the university that I work for in my day job. That's Brunel University in West London. And it's a home pyrolyzer. So for pyrolyzing domestic waste, and it uses heat pipe technology to make sure that you have a uniform temperature throughout the chamber where you put your domestic waste, so that we avoid producing any polyaromatic hydrocarbons, which of course are carcinogenic, and obviously you don't want to be making those in the home. It's called HERU. I think it's called Home Energy Resources Unit, and the idea is that practically anything that is produced as waste in the home can be put into this device. It's about the size of a washing machine, and you get 3 products out of it. You get your charcoal, which you can then combust further to produce an ash, which you can dispose of quite easily. It produces an oil, and obviously it produces heat. And the idea is that you use these products to form more heat, which you can then use to supplement the gas that you're using in your boiler, and reduce the energy consumption in the home. Also, obviously, reducing the amount of material sent to landfill. If you're interested in that, obviously the case studies show various links, but there is a website called myheru, that's myheru.com, if you want to get further information. But the really clever bit is the heat pipe technology, which Brunel has developed as part of its research activities here. And that's, I hope, answers your question.
Yes, just had one quick follow-up on that. What sort of wastes can be used in the HERO system?
Well, it's actually a lot of tests have been done on a variety of materials. The usual, food wastes, even disposable nappies. We are currently testing the device on plastics, particularly PVC, because obviously we want to see what happens with the chlorine, and actually, because it's a low temperature pyrolyzer around 350 degrees, and that's kept at a uniform temperature, as I said, across the bed by these heat pipes, we've shown that the chlorine actually remains in the ash. So it is actually safe to use it on those types of plastics within the home. Basically, most home produced waste.
Thank you, Steph. So now we're going to go to a question from our past Vice Chair, Jeff Maitland. Do governments across the world appreciate that energy and resource efficiency is a low-hanging fruit solution to decarbonisation? And how can we get them to play their role by providing incentives to individuals and companies or increasing awareness?
Yeah, wow. Okay, so I mean, I guess I can answer for the UK. I mean, I think in the UK, at least, the Clean Growth Strategy does talk about energy efficiency, particularly. I don't think it goes as far as thinking about resource efficiency, and I think there's quite a lot missing from the current policy framework, even in the UK. But there is at least, on the face of it, an acknowledgement that energy efficiency is a key part of the solution to get the UK to meet its obligations to 2030, and indeed they've put the government have put in that targets around what they expect organisations and businesses to be able to achieve by 2030, and also what they want to do in terms of their own estates. Unfortunately, I don't think there's the policy in the background behind that to really drive the things that need to be done in terms of some of the barriers we talked about. On a broader level, I think it probably is. It varies from nation to nation as to how widely accepted energy and resource efficiency is as a genuine solution to help us meet our obligations. And I think, as chemical engineers working across the globe, we've got opportunities and should always seek out opportunities to help share that message and promote in our own regions.
I think just to add to that, for many years I taught a master's course on energy technologies, and I used to use the IEA's annual Energy Technology Perspectives report. And over the years, I noticed within that report that energy efficiency was gradually being replaced or joined with resource efficiency. And I think work such as Mark's been doing and others on circular economy has really started to make big inroads into government thinking and organisations like the IEA. And when it appears in reports like that, which we can all influence by the type of material that Mark has led the production of, which is really excellent, that's a really good route to influencing governments on how we should be meeting our emission reduction targets.
So on a similar note, we have another question here. We've recently seen people's reticence to paying the so-called carbon taxes, particularly in France and Ireland. So how do we overcome this obstacle? And are taxes the right incentive for energy and resource efficiency?
Yeah.
Mark?
Hi. Yeah. No. So no one likes tax, right? I think that's probably a universal truth. But there's one thing that's certain is that we all have to pay taxes, and the question is probably more about what's the right balance of taxes in the background against all the commitments that we've made, and how do you encourage people to take energy and resource efficiency seriously and really value the finite resources that we have on our planet? And there's various strong arguments for carbon taxes, and you know, if you look at places like British Columbia in Canada, they've got a really progressive carbon tax, if that's the right word to use, in that it's very expensive. I think in the UK, whilst energy gets a lot of focus in the news, it's relatively cheap still, despite the taxes that are loaded on it for the benefit we get from it. It's part of the, I mean, if you think about, rather than comment on whether it's the right thing, if you think about governments and the policy levers that they have at their disposal to meet the commitments that have been made under Paris, there's very few things that they can do. One of them, as we get closer to the deadlines, is to ramp up things like the tax to change behaviour. And whether it's the right thing or the wrong thing, I suspect we'll see more of it as governments get closer and closer to missing their targets, and therefore have to do everything they can or within their power to try and encourage change.
And following on from that, what do you think is the biggest single challenge to meeting the 1.5 degree target?
It's a great question. Look, I mean, I think, and I'm not suggesting that energy and resource efficiency is anywhere near the whole part of the solution. It's one part of the solution, and there are challenges everywhere in terms of the way we live and the things that we consume and the way we treat resources. I don't want to, like, you don't want to be pessimistic. I think we have got an opportunity to make the change, but we do have to act pretty fast. And I think the challenge is getting everybody to change their behaviours in order to meet these really quite extreme reductions that we need to see around the world. You know, not least the food that we eat. We haven't talked much about food production, particularly today, but there's lots of measures out there at the moment, and a focus on thinking about where the food that we comes from, and that feeds into one of the other ecological boundaries we talk about, the nitrogen and phosphorus loading and so on for farming, land use change, where we're turning over huge amounts of land to agriculture and farming, and in many cases large amounts of land to grow food to feed meat, and transitioning away from meat eating is a difficult ask for many people, I would think. So look, there's no one thing, but that you know, there's a few things I think that are going to prove rather difficult.
Can I add that clearly it's a huge challenge, and many people would think that we've probably already missed that target because of the time lag it takes in the atmosphere for these impacts to hit us, and we are still very dependent on fossil fuels. I should say that when we've attended now, I think 3 of the Conference of Parties meetings on climate change as the Energy Centre, and we've attended, but because we've been arguing that many of the technologies that we require already exist, and what's missing is the systems approach that chemical engineers are highly trained on. And this was, you know, why the Energy Centre was formed in the first place. And when you look at our carbon capture and storage report, for instance, you know, it starts on that very issue that most of the scenarios that show how we could possibly reach the 1.5 degrees target show quite large scale CCS, and we all know that actually at the moment we've only got, I think it's something like 37 projects worldwide, hardly making a dent on the amount of carbon that we would need to sequester from the use of fossil fuels. So the Jeff's report was very much focused on not necessarily the technology itself, but what is needed to get that technology taken up and commercialised and out there, if we've got any chance of meeting that target. So I think, as Mark said, there's a big responsibility in all of us, but saying that, there are many barriers out there as well to enable change and to encourage change, and that's part of the mission of the Energy Centre, is to provide informed comment and ideas and suggestions to governments on how we can progress those technologies to the scales that are required.
Thank you both. We've just got time for one more quick question, but any further ones, please do keep them coming, because we'll ensure that they are answered one way or another. So we have one last question from Jim Petrie. Given energy and resource efficiency has a large focus to influence policy, and the Energy Centre's aims to be more meaningful for IChemE members internationally, can the Energy Centre Board consider how to align these two, particularly with regards to policy issues in the IChemE member countries?
Good question.
Yes, great question. I mean, Stefan, I think what I was going to talk about first was our plans for 2019. So today is very much launching the guide and starting to launch some of the case studies. We want to see more coming out of it. But what we would like to do in 2019 is to set up a number of workshops around the world to engage members in each country where we are represented, as a platform and a starting point really for trying to get those policy conversations going within different member states. And energy resource efficiency is a universal thing. I mean, you can do this everywhere. The question is whether you can get the right incentives in place, get the right encouragement in place to act now and act quickly, because as Stefan said, of course, CO2 emissions are cumulative in the atmosphere. We need to get on with it. And it's a bit back to the last question in terms of what's the toughest thing to meet the 1.5 degrees. I think the toughest thing is doing things fast enough, probably, on reflection. Steph, I don't know if you want to add some more about the workshops and on what we're planning for this year.
Well, certainly that's, we just had a board meeting last week, and certainly, we are always conscious that it's easy to fall into the trap of being UK centric. The IChemE headquarters are here, and that's always going to be a challenge for us, but we do have very active international members on our board. As I said at the beginning, these workshops that we've held overseas have been led by our board members. So we have board members from Australia, South Africa, Malaysia, Singapore, Qatar. So we cover, most of the regions where the IChemE has significant numbers of members. And as Mark said, we've now put it to our board members in those regions to start to organise workshops and activities around the ERE publications. And we provided them with a template of the kind of activities that we could do internationally, because it's very important that from these lessons that we're learning on how we're influencing UK government to be able to influence governments elsewhere. And we've been successful partly in that in Australia, but we need to make impacts in other countries, particularly the countries of Africa. So
thank you, Steph. We've got 1 minute left. All questions will be, the Q&As will indeed be published with a PDF of the slides. So if you'd just like to wrap us up, then we can. Okay.
I mean, that was the last point, that Africa is a particular focus for us. So yes, so thanks everybody for joining us today. It's been a pleasure to present the work of the IChemE Energy Centre to you. We hope you found it informative, interesting, and an enjoyable event. Please do get in touch with us if you'd like to get involved. Here are all the ways that you can do that again. But you'll be getting copies, and we'll endeavour to answer all the questions that we didn't cover, we didn't find time to cover today. So thanks very much. And so for now, goodbye from all of us. Goodbye.